Okay, now we're going to look at what we call evaluating functions. Now, you know functions are set aside and are labeled by this notation f of x. So this is just a function of x, which is 3x squared minus 5x plus 2. Now, the notation f of x is versatile, and that's what we want to try to help you recognize with this presentation. So here, this says go to the function f and take all the x values and replace them with 2. So it says evaluate the function f at 2. So every x is replaced with 2. The computation is done, squaring, multiplying by 3, okay, and multiplying by 5, adding them together, and it evaluates to 4. So f of 2 is 4, okay. Another example, what's f of negative 3? Same thing. Evaluate function f with the input value of x at negative 3. So going to function f, throw all x values, replace all x values with the value in parentheses here to the computation and come up with a simplification. What this is saying is take f of 2, which we've already done, which is 4, and multiply it by negative 3. So that obviously then give you negative 12. So we can call back on what we've done previously. This is supposed to be raised to the second power. So, but you could see that from up in the original problem. Okay. F of h. Well, again, it's almost you might say, why are you even doing that? But all we're doing is simply replacing x with h. Okay, as you can see here. If it said f of p, then x would become p, or whatever it is that is in here becomes the value assigned in x. Let's look at another function, g of x, which is this linear graph, a line, negative 2x plus 7. If I said, what is g in negative 6? Simply means put in negative 6 for x, do the computation, outcome the result, okay? Then this one is a combination of things. What is g of negative 6, which we found was 19, plus f of negative 3, which we found over here was 44, and you add them, and that's 63. So that's exactly what it's telling you. There's no sense in doing it again. We've already done it here, so he's just summing those things, okay? This one says, what is g of 1 minus 4, what is 6 times g of 1 minus 4 times f of 2? Well, g of 1 can easily be said to be 5 times 6 is going to be 30 minus f of 2, and f of 2 I think we did over here was 4, and 4f of 4 would give you or 4f of 2 would give you 4 times 4. So that's how that computes out. Take a look at a couple more. Okay, g of x plus 2. Now this is a little bit more involved, but what it's saying is go to function g. Okay, no particular reason, lowercase or uppercase, just got a little sloppy on my notation there, but it still refers to this function g. All x's are replaced with x plus 2, and so we're given negative 2 times the input value now of x plus 2. Distribute negative 2x minus 4 plus the 7 is negative 2x plus 3. Okay, and we look at another one. Here, this is saying 3 times g of x plus 2 squared. Well, we already know what g of x of 2 gave us. It's over here. This is g evaluated at x plus 2, or sometimes read g of x plus 2, gives us this negative 2x plus 3. We're asked to square that, okay? That's lost my notation there, but that's meaning negative 2x plus 3 squared. Don't forget your order of operations, calling for doing the exponents before multiplying. So square that all out, which is 4x squared minus 12x plus 9, and then triple it. And there's your end result. So 3 times fg of x plus 2 quantity squared is this trinomial expression right here. And lastly, let's take a look at this one. This is saying what is f of x plus 1 minus f of x. Now it seems we've already done f of x plus 1 over here. F of x plus 1, okay, or maybe we didn't. So let's go through and do f of x plus 1. which is again going to function f, replacing all x's with x plus 1, and doing the operation that's called for. So 3 times x plus 1, the quantity squared, we have to expand that out. That's x squared plus 2x plus 1 times 3, which gives us 3x squared, 6x, and 3, minus 5 times x minus 5, distribute the negative 5, plus 2, bring down your terms, combine, okay, and we end up yielding 3x squared plus x, we lose the 3's. Okay, so I would run through that one again. I would do that on your own. Go and evaluate f of x plus 1. Again, it implies, okay, sorry about that, it implies that we're going to function f, all x's are being replaced with x plus 1, and we're doing the algebra to simplify it. Now over here, we're going to say, what is f of x plus 1 minus f of x? That is, f of x plus 1 is over here minus the original f of x function, which is stated up here at the beginning, okay? So the result, f of x plus 1, we carry over from here, which is 3x squared plus x, minus the original function, and we watch the signs here because they're going to, this is being subtracted, so be cautious because everything to the right of that sign is going to flip. Okay, so this becomes minus 3x squared plus 5x minus 2. We combine our terms, and we see we end up with 6x minus 2. So the function, so the emphasis on this presentation is to discuss the function notation and the versatility of the function notation. In short, f of x is a function, and if the x value is replaced with any number or an expression, then it means that number or expression is thrown into the function as the new value of x, and you do the necessary computation algebraically to simplify it. Okay, so that's our discussion on evaluating functions.